Assalamu alaikum. Hello everybody. I believe that you are doing well. This is a new video about integral, the third type of integral, limit type and definite integral. So, if we have to deal with this kind of limit type, how can we proceed? So, we call this integral e3 of x. e3 of x is equal to the integral a, b, c are real numbers. A is different of 0. Otherwise, we get just the square root of bx plus c, which is very simple. Let us transform this integral to this one. A brace, second brace, x plus b over 2a square minus plus c over b minus b square over 4a square. And we close the brace. Here we have x squared plus b over ax plus b squared over 4a squared, so minus b squared over 4a squared to get exactly this one. And this is equal to the integral of dx over the square root of a x 2ax plus b over 2a square. Here we have plus 4ac minus b square over 4a square. We close the brace. So we have 4ac minus b square over. In this case, we have 4ac minus b square positive. So since this is positive, delta is negative, it takes this form. And if delta is positive, it takes here minus. So let us set m square plus minus equal to 4ac minus b square over 4a square. And this integral takes the form with this symbol. The integral takes these two cases. The integral dx over the square root of a times 2ax plus b over 2a square minus m square. This case is delta greater than 0. If delta is greater than 0, this means b square minus 4ac. If this is greater than 0, here we get minus m square. Why? Because here we get minus b square minus 4ac over 4a square, which is m square. And it is equal to the integral dx, the square root of a 2ax plus b over 2a square plus m square if delta is less than 0. So we can summarize this by writing, this under this form. So this is equal to integral dx over the square root of a times 2ax plus b over 2a square plus minus m square. We can take this form such that plus minus m square is equal to 4ac minus b square over 4a square. And here we can discuss cases. This is equal to, let us put the change of variable t equal to 2ax plus b over 2a. Then this gives us 2a dt equal to 2a. We can take 1 over m, and here we get m, and here we get plus or minus 1. Let us take this change of variable is more accurate. So 2a m dx, 2a dx equal to 2a m. Since a is different of 0, so we can cancel 2a with 2a, and dx will be equal to m dt. This one is equal to 1 over m, capital M dt, over the square root of a t square minus plus 1. And here we can discuss cases. We can make steps. This is equal to, we can cancel m with m, and finally we have dt over the square root of a times t square minus plus 1. Here we have these cases. T square plus 1 is always positive. So if a is positive, we have the first case. If a is positive, this is equal to 1 the square root of a, the integral dt over t square plus 1. We have this first case with a positive, for sure a positive. The second case is when 1 over the square root of a, the integral dt over the square root of t squared minus 1, and this case deals with the case a positive and t squared minus 1 positive. And the third case, when a is negative and t squared minus 1 is negative, because t squared plus 1 can never be negative. So this case is adequate. A negative, so minus a is positive, and we can write this under this form. T squared minus 1 negative, this means what 1 minus t squared positive, and we get this one. So this case is under this condition. under this condition. For each case we have for this case, this is equal to 1 over the square root of a arg SHT plus C. For this case, a positive, so which is equal arg SHT plus C. This case, a positive. For this case, this is equal to 1 over the square root of a, 1 the square root of a, arg CH T plus C for a positive and T square minus 1 positive. And for the last one, this integral 1 over the square root of minus a arc sine t plus c, and this case is for a positive and t, for a negative and t squared minus 1 negative. T is equal to the variable t is equal from this t is equal to 2ax plus b over 2a capital N. Then we replace t by its value, and we get the integral of this case. So, at a summary of this integral, we have just 3 possible cases. The 3 possible cases deal with a positive, and we have delta is positive, is negative, sorry. In this case, we have arc SH. A positive and delta negative, we have arc CH, 1 over the square root of a arc CH, arc, not arc CH, arc CH. And the last case, when a is negative and t square minus 1 is negative, in this case we have 1 over the square root of minus a arc sine t plus c, such that t is equal to this expression. As an example, the example that we presented at the beginning of this video, we will turn to this example. The example, just one case, we cannot give just one example and solve the 3 cases. Actually, I can say that these cases will appear when we will solve the finite integral. In such situation, we know if the t square minus 1 is positive or it's negative, because we have boundaries, so we have endpoint and final point. For this reason, this is very useful when we deal with Riemann integral or the finite integral. So the case x squared plus x plus 1 this is an example, can be write as dx over the square root of x plus 1/2 square. So here we have x squared plus x plus 1 over 4, so minus 1 over 4 plus 1. And minus 1 over 4 plus 1 can be written as 3 over 4, so plus 3 over 4. Here we are in the case when delta is negative, 1 square minus 4 is negative, which is equal to dx over the square root of 2x plus 1 over 2 times m m is the square root of 3 over 2, so 2 over the square root of 3 square plus 1, so this is constant, and we get just the square root of 3 square plus 1. Using the change of variables, so we put t equal to x plus 1 over the square root of 3. This gives us as an application of what we saw before. This is 1 over the square root of a, so this is equal to dt over the square root of t squared plus 1, which is equal to arg s h t plus c, which is equal to arg s h t is equal to 2x plus 1 over the square root of 3 plus a constant. And here we have, with change of variable, one has the square root of 3 dt equal to 2 dx. So dx is equal to the square root of 3 over 2 from this side, and from the another side here we have here when we take this we get 2 over the square root of 3, which will be considered with this one, so we get just exactly this one. Thank you for watching. I hope that you enjoy watching this video. They are not very attractive since they are mathematics, but I try to do my best. See you next time.